All right, let's tackle the ultimate cosmic question, right? This is one that pushes us to the very, very edge of physics and our own imaginations. We're going to go on a journey, a one-way trip to see the final show the universe has to offer from the most extreme seat in the house. The source material for this kicks off with this absolutely beautiful quote from Emily Dickinson. And it's just perfect, isn't it? It sets the stage for a truth that's so stunning, so completely mind-bending, that you have to look at it sideways, reveal it a little bit at a time. Otherwise, it would just be too much. So when we ask this question, we're not just talking about, the grisly physical end of being stretched apart. That's spaghettification, and yeah, that's part of it. But what we're really getting at is the view. What would you actually see? We're setting out to witness that final, spectacular panorama of the entire universe. To figure this out, we're going to follow an imaginary explorer on their final descent. And not just into any black hole, but a supermassive one. A real monster, 1 billion times the mass of our sun. Why so big? Well, because with a black hole this massive, the killer tidal forces won't get you right away. That gives us a little more time to, well, enjoy the show. Okay, so how do you even begin to picture what you'd see when you're falling at these just unbelievable, ever-increasing speeds? Well, physicists have this really clever thought experiment that helps us visualize something that's, well, pretty much impossible to see for real. I want you to imagine you're floating, totally weightless, inside your own personal spaceship. It's a transparent sphere that's falling right along with you, and on its surface, you can literally map out the sky from your unique, plunging perspective. Think of it as your map for this whole trip, letting us track the growing darkness and watch the stars themselves get twisted into impossible new shapes. It's your personal window on a seriously warping space-time. Now, this concept is absolutely key. In the language of general relativity, this makes you a rain observer. The best way to think about it is like you're a single raindrop in some cosmic storm, just falling perfectly straight in. You're in perfect free fall. You don't feel any engine pushing you or any force slowing you down. Just the silent, relentless pull of gravity as your little planetarium dives into the abyss. All right, our journey starts way, way out from the black hole. From here, the first signs of what's coming are subtle, almost unnoticeable, really. So let's start the countdown. So this is our journey, a countdown to the end. And notice how that timeline just compresses like crazy. What begins as this slow, almost invisible change over decades suddenly accelerates into a frantic rush over just a few hours. The darkness ahead swells from a tiny dot into this monstrous void, pulling us toward that final, irreversible step, right across the event horizon. So way out here, with 26 years still to go, you'd honestly probably miss it completely if you didn't know exactly where to look. It's just this little perfect circle of blackness in the sky, maybe twice the width of our full moon. The only clue is that the starlight right around its edge looks just a little bit bent. Okay, now things are about to get really, really weird. As we fall closer and start picking up some serious speed, this strange effect from special relativity kicks in. It's called aberration, and it is going to completely and radically change our entire view of the cosmos. Here's the best way to think about it. Picture driving your car in a downpour. Even if the rain is falling perfectly straight down, when you're moving fast, it looks like it's coming at your windshield from the front, right? Well, the exact same thing happens with starlight. As your speed gets closer and closer to the cosmic speed limit, light from every direction, and I mean even from the stars directly behind you, gets warped and appears to be coming from in front of you. And just how fast are we talking? Well, right as we get to the edge of the event horizon, the ultimate point of no return, our imaginary explorer is now screaming along at 97% the speed of light. And at that speed, this aberration effect isn't some subtle thing anymore. Oh no, it's extreme, and it has some absolutely profound consequences for what we're about to see. And this is where the weirdness really hits you. The entire universe of stars, that whole 360-degree view of the sky, starts to gather up in front of you. Everything that was behind you is swept forward, compressing into this brilliant, intensely bright ring of starlight that frames the ever-growing circle of pure black. And we've done it. We've crossed the event horizon. There is absolutely positively no turning back now. Any light we try to send out will just fall inward with us. But the show, the final cosmic light show, it's not over yet. So now that we're inside, there are two distinct dangers racing to end our journey. First, you've got the insane energy of all that starlight, which is now being gravitationally blue shifted into lethal high-frequency gamma rays. And second, you have the tidal forces of gravity, which are trying to stretch you apart like a piece of spaghetti. So the big question is, which one gets you first? Well, the physics here gives us a very clear answer. As we get closer and closer to the center, the energy from that starlight bombarding us gets stronger, for sure. But the tidal forces, that difference in gravity between your head and your feet, they grow exponentially faster. It's not even a close race. So the crucial takeaway here is that it's the gravitational stretching, the infamous spaghettification, that's going to end your experience. The intense radiation would definitely be a problem, but you simply won't be around long enough for it to matter. The end comes from the raw, overwhelming force of gravity itself, and it all happens in the final fraction of a second. So what does this grand finale even look like? Well, because of that crazy aberration effect we talked about, pretty much every star in the sky has now rushed into your forward view. If you could look back, your rearview mirror would be empty. There's nothing but darkness behind you. But your forward view, it's an unbelievable spectacle. You are now seeing multiple images of every single star in the universe. Light is bending and wrapping around the black hole again and again before it hits your eye, creating these infinite reflections. It looks like the stars themselves are multiplying right in front of you. All of this light, every star, every galaxy, all seen countless times over, is being squeezed by the warped space-time into an intensely bright, rapidly shrinking band, a circle of pure light, getting thinner and brighter with every passing microsecond. And this is it. This is the last thing you see. A single, brilliant, awesome ring of light splitting the sky in two, separating the absolute blackness of the singularity ahead from the profound blackness of the universe you just left behind. A final, perfect circle containing all of creation. And that final, breathtaking sight leaves us with a question that, right now, science simply cannot answer. What happens at the center? What lies beyond that awesome ring? The truth is, we just don't know. The laws of physics as we understand them completely break down, leaving only the mystery.